Our second type of equation in this section is a radical equation. A radical equation is one in which the variable occurs in a square root, cube root, etc. We'll be considering, though, for our class, strictly square roots, but higher roots would be solved using similar methods. Okay, and we'll also only be working with equations containing one root. A simple square root equation is something like the square root of x equals 9. Okay, so to solve a radical equation, we're going to go through the following procedure. Okay, so first, if necessary, arrange the terms so that the root is isolated on one side of the equation. And then to cancel a square root, we're going to square both sides of the equation to eliminate the square root. And just note this will often require FOIL on the other side. Solve the resulting equation. And then the last thing is make sure you check all of your proposed solutions in the original equation. It will often happen in this type of equation that we get a solution that does not work in our original problem. So it's absolutely essential that you check your solutions for a radical equation. Okay? Through the process of squaring both sides, you possibly have inadvertently introduced a solution that doesn't work in the original equation. Okay? These types of solutions that don't solve the original equation are called extraneous solutions. Okay, so example 2, let's solve the square root of 2x minus 1 plus 2 equals x. So first thing is to isolate the root, and for this problem that would involve subtracting 2 on both sides. Okay, so now our square root is alone. And then we want to square both sides of the equation to eliminate the root. So square this and square this. When I square a square root cancels. On the other side, you have to be very careful. This is the most common mistake on this kind of problem. Squaring x minus 2 does not mean just squaring x and squaring 2. When we square something, it means take it and multiply it by itself. So it's actually a FOIL problem. So if you FOIL this, we get x times x is x squared. X times minus 2 is minus 2x. Minus 2 times x is minus 2x. And negative 2 times negative 2 is positive 4, so plus 4. So this results in a quadratic equation with x squareds and x. So our strategy is to get everything on the same side and combine like terms. So we want to subtract 2x and add 1. So we have 0 on the left. On the right, x squared, negative 2 minus 2 is negative 4, minus another 2 is negative 6x, and plus 4 plus 1 is 5. So we want to solve that quadratic. You can either use the quadratic formula, or I will tell you in this section, all of our problems will factor. Okay, so you can factor every single one of these. This one, since there's nothing in front of x squared, it would be one of the simpler ones to factor. We only need to consider the factors of 5. And there's only 2 factors of 5, 1 and 5. If we do negative 1 and negative 5, we will be able to get negative 6 in the middle. So this factors into x minus 5 and x minus 1. If I set each of those equal to 0, I get x equals 5 and x equals 1. Okay, so we want to take each of those one at a time, go back to our original problem, and make sure that it actually solves. So let's start with 5. If I put 5 into my original equation, I'll have 2 times 5 minus 1 plus 2 is supposed to equal x, which is 5. So this is the square root of 10 minus 1, which is 9, plus 2, and that's supposed to equal 5. Square root of 9 is 3, plus 2, and that does equal 5. So far I know that 5 is part of my solution. The other solution I got was 1. So if I go to my original equation and put 1 in for x, 2 times 1 minus 1 plus 2 is supposed to equal 1. So we have the square root of 2 minus 1 is 1, plus 2 is supposed to equal 1. The square root of 1 is 1, plus 2 That's 3. So that does not equal 1. So when I put 1 into my original equation, I get something back that's not true. So that tells me then that x equals 1 is not a solution. And my only solution is that x equals 5.